Hey everybody, this is Mr. Walsh, and in this video we're going to describe the difference between accuracy and precision. The way that I describe accuracy is I look at this A. Accuracy is how close you are to the actual answer, okay? And this is usually because of number, but it also could be because of a trivia question, okay? An accurate answer is one that is close to the actual answer. If I am looking for the length of the room and it's supposed to be 10 meters and I get 9.8 meters, that's pretty close, okay? This is the actual and this is the measured, okay? If I have that same room and I get 1,032 meters, that's way off. This is not accurate, okay? So accuracy is how close you are to the actual answer. And earlier I said it could be a trivia question. So if I say, what color is the sky? And you say that the sky is yellow, okay, that is not close at all. That is not accurate. It's not close to the actual answer, okay? But if you said that it was like light blue, but the sky in this moment is like a dark blue, maybe it's closer to sunset or something, okay, that's accurate. The sky can be light blue, so that's where you can get accuracy with kind of qualitative measure. Precision, the only way to get precision is when you have a group, and what happens is the group of data have to be close to each other. It doesn't have to be accurate, they just have to be close to each other. So the easiest way to discuss accuracy and precision is imagine a target for like shooting arrows or something, okay? And so you can see we have 4 arrow marks on each of these targets, okay? And so if the actual answer, or the actual target is supposed to be the middle, is supposed to be the bullseye, and all 4 of these hit the bullseye, that means it's accurate. But the fact that they're all grouped together very closely also means that they are precise. Okay, I'll come down to these in a minute, this check mark and X here. Okay, so now in the second example, you can see all 4 of these are grouped very tightly together. I can make a circle around them pretty easily. So I know that they're precise, but notice they are very far away based on the target from the bullseye, okay? So they are not accurate, okay? Now the hardest one to figure out is this one. Notice that these are not precise. They are not grouped together. A small circle does not circle all of these things. So we have to kind of take them separate. So they are not precise, but if you kind of draw an average of where this falls, notice it falls into the bullseye. So they're saying that this is accurate because kind of the visual average of these is in the bullseye. Okay, so this is accurate but not precise. Okay, and the last one, you'll notice that these 4 are all spread out, and the middle of them is not the bullseye. So this is not accurate and not precise. Now, to help you along is that this is a situation that's very easy to see. We will use that. You will see that. This situation is another one that's very straightforward to see and to measure and to talk about. This situation is not. So this situation is one that you are likely not to see very often in assignments. Okay, you're not going to see accuracy and precision. Okay, you're not going to see something that is accurate and not precise. Okay, it's just not something that is easy or not something that is clear when doing this. And the last one, not accurate, not precise, this again is another one that is pretty straightforward to see. So you will see this. So you'll see 3 out of the 4 of these cases. Okay, so this is a golf green. You can see the green around here. It's not green on your screen, but it was when I made this slide. And we drive the ball, and each golf ball lands here in the green. The target is this hole right here. Okay? It's maybe not clear because the flag is up here, but remember in golf, there's the flag goes in the hole. So, these 3 golf balls are grouped together. They are precise. Are they accurate? Well, if this is the target, this is a long way off from the target based on the size of the green. Okay? So these are not accurate. Another situation here is same green, but notice we have a golf ball over here. They are not grouped together. Okay? So they are not precise. And notice they are not close to the hole. Okay? Because they're not close to the hole, they are also not accurate. Okay? And I know, like, if you were to average these out and kind of draw the middle, okay, the middle is nowhere near the hole either. So not accurate, not precise. So here's a scenario where the teacher is giving a test and sets the target score on the test to be 90%. Okay? That's what that teacher wants on the test. And then the 10 kids took the test and got these grades. Okay? You can see the grades. You can judge them to yourself quietly. Okay? And then I decided to take the average of each of these and come up with an average of 77%. And we want to know if they're accurate or precise. Okay? So, precision is the easiest one to look at. Okay? We'll take the lowest number and the highest number. So we go 50 to 100. And so that's the range. But the highest score on a test is only 100. So this covers half. The precision covers half of the possible scores. So they are not precise. Okay? There's no way that those numbers are precise. Okay? They are not grouped together. Okay? And now, to determine accuracy, this is where numbers can kind of be wild. This is what we wanted to be the actual. Okay? That's what we wanted to be the actual 90%. And we take the average, and when we compare, we get 77%. So in order for a number to be accurate, the cutoff is about 10%. If there's a 10% difference between the numbers, then it's probably not accurate. Okay? So in high school, 10% is about the range that I use. And then when we do college, in college it's about 5%. And then in graduate school, we want it to be even closer, sometimes down to 1%. Okay? But, so these are more than 10% difference. Okay? 90 versus 77 is about a 13% difference. These are also not accurate numbers. Okay, so there you have it. Accuracy and precision.